Okay, so this is just a review class. So chapter I think it's better if we start from chapter 4 and then chapter 5 and then chapter 3. So we start with our recent chapter, which is chapter 4. Chapter 4 is multiple integration. So you can have double integration, triple integration, and also you have line integral. Chapter 4, and then you have in chapter 5, you have extremum for multivariable. And then in chapter 3, you have derivatives for multivariables. Okay. Right. So I will start with line integral first, and then I will go to multiple integral, and then extremum, and then if time permits, I will go to the derivative of multivariables. Okay, let's start with line integral. Okay, for example, if I have something like my line integral example. Okay, example. Evaluate line integral. Saya dengar macam ada suara di sini. Line integral 2x minus y plus 4 and dx plus 5y plus 3x minus 6 dx. No, dy. Okay. So let's see. Let's pick the p and the q, the multiplier for dx and the multiplier for dy. Because I have a small whiteboard, I think it's better we can just take this one. So let's try to take note on that. Because we are going to use p and q throughout our. So my plan for this is I have three methods to solve this. The first one is the harder one. Second is a little bit easy, but not that easy. And the third one is called green theorem. Okay. I didn't mention in the class for green theorem. Why? Because you are going to use green theorem in your student-centered learning, your SEL project, which I already posted on Future Blast. Okay, so let's take note on this one. Okay, let's see this one, and then C. What is C? What is C? C is what it says. He is a triangle. He is triangle with vertices of 0, 0, 3, 0, and then 3, 2. So first of all, we notice that this is the P, and then this is the Q. Okay, and then this is the lines. Okay, let's try to sketch this one. All right, 0, 0. Everything is positive, so I can take this is 0, 0 at the origin, and then 3, 0 right here, and then go up 3, 2 above this. So this is 2. So my line is this line. My line integral will be this, this, this. So my orientation is on clockwise. This is the convention. Okay, so from 0, 0 to 0, 3. Okay, the hard one. Let's see. So the first line is on this. It goes from 0 to 3. 0 to 3. On what line? This is on y equals to 0. Okay, so my integral from y to 0. And then from this to this, 3, 0 to 3, 2, this point. So my line right here is, my line equation is x equals to 3. So that's just my, you don't have to calculate that because it's easier to see the line equation. How about this one? So this is 0.32. Okay, how about this line? So this line is an equation for y equals to 2/3x, 2/3 x. So this is 2/3x. So that's easy to see because it goes to the origin. It goes to the origin. All right. So now we need to evaluate 1, 2, 3. Okay, first of all, we need to evaluate on the first line. Let's say this is L1. So can you see? So on L1, we have y equals to 0. So y equals to 0. I don't know why, but that one is trying to refocus. So therefore, dy equals to 0. So that's easy. Why? Now we have, let me take some. So now we have this dy. So this is my vacuum. So what now we have everything right here becomes 0 because dy is 0. So we only left with this term. Okay. So we have the integration. I haven't set up my boundaries for x yet. So 2x minus y is 0, so nothing, plus 4 and is that clear? So the boundaries, the limit for the x goes from what? From 0 to 3. X travel from 0 to 3. So dx is from 0 to 3. Are you guys with me so far?
Yes, Doctor.
So evaluate this. What do you get? So that one is the 3x squared plus 4x, and that one should be 3x squared, 9 plus 4x, 9 times 9 plus 8. So that one should be 3. So this is going to be x squared, right? So x squared, do this, x squared plus 4x goes from 0 to 3. So this is 9. 9 plus 12, this is 21. Okay, so the first line right here is 21. Okay, let me do on the second line. On the second line, let's say this is L2. Okay, so on L2, I have my equation x equals to 0. No, not 0. X equals to 3. So therefore, my dx is 0. Why 0? Because this is constant. 3 is constant, x equals dx equals to 0. So therefore, you can see that this is quite good, nice, because now, now we have this term goes to 0 because we have dx right here. Dx is 0. So we only have dy term. Okay, so now we have integrate. I didn't set up my limit yet. 5y plus 3x, which is 3. So 3 times 3, and then minus 6 dy. Okay, so dy, how about dy? dy, the change in y, in y goes from 0 to, what was the value? 2. So y goes from 0 to 2. My limit for integral is from 0 to 2. So this is quite easy to evaluate because now we have 3, 6. Also, this is just plus 3 dy. Don't forget this one. And then this will be 5y squared over 2 plus 3y from 0 to 2. And then that will be 10 plus 6. So that will be 16. So that is 16. So on this line, it's 16. Now we need to evaluate on this line. Okay, let me erase everything. By the way, this one is from tutorial question. I forgot which tutorial, but it is on tutorial. Okay, last line. Last line is on this line. So y equals to 2/3 x. Okay, so dy equals to 2/3 dx. Okay, so we now can insert or substitute dy in terms of dx. You can also do the reverse part, x in terms of y, but you need to make sure that you have the correct coefficient. Okay, let's see this one. Let's substitute y equals to 2/3 x. Okay, so on the first equation on this one, I have y 2x minus 2/3 x. So this one is x, this one is y, plus 4. And this is dx. Okay. So I haven't set up the okay, let's see. The next part is 5y plus 3x minus 6. Let me do it. Okay. So the whole thing is 5y. 5y is times 2/3x. Okay. And then plus 3x minus 6 times, how about dy? dy is 2/3 dx. Okay, so what I did is just substitute y, substitute dy. Okay, and then x. How about x? X goes from where to where? Okay, x goes from where to where? X goes from this point to that point. So if you look at the point 0, 0, right here, so look at the x part. X is this part, this is 3. 3 goes to 0. So my boundary, so my AB should be from 3 to 0. Okay, and I think this is easy integration. So if you do this integration, the thing you need to understand that this will be a negative because it goes from big value to a small value. Okay, just do the calculation, and then the value right here is minus 25. Okay, I think you can do that. That's easy. Just try on your own, try to practice and see if you get 25. Okay, and then the whole thing is just the summation of the line integral. Okay, so the whole thing will be, so the whole thing on C T dx plus Q dy, in this case, is the first one, if I'm not mistaken, is 21. The second is 16, which is minus 25. And the answer will be 37 minus 25 is 12. So the answer is 12. Okay, so that's the first method. The second method is I can use parametric equation. What does it mean by parametric equation? You can express x and y into another variables, like we did for circle. Circle we use theorem. Okay, how about lines? Okay, for lines, let's say we can also use something like this, parametric equation. Let's say, but you need to be creative. How to create the function parametric equation. Not to, right. What to do? So if I use number two method is parametric equation. If you remember what I did in the first, in the beginning of our line integral, I said I expressed x in terms of px, pt, and then I express y in terms of psi. Okay, if you remember, I explained this in terms of another function of t, another function of t. Okay, for circle we use cosine. This is a cosine t, and then we also use a sine. Usually like that. But if you want to use a line, if it's a line, linear line, you can say something like this. You can say x equals to a plus b of t, and then y equals to alpha plus beta of t. Okay, and t goes from 0 to 1. Always like that, 0 or 1. Okay, let's try to evaluate the first line. The first line is line number 1, which from 0, 0 to 3, 0. I want to find out the equation, parametric equation of this. Okay, so I write x equal to something plus t, and then y equal to something plus. So if you can see that, when say, and then in t coordinate, it says t equals to 0, and then t equals to 1, because I said from 0 to 1. Okay, you can see if t is 0, everything is 0. If t is 1, only x is 3. So I can see that this is the x equals to 3t, y equals to 0. And therefore, the x in terms of t is the x equals to 3dt. Okay, and then my change of variables will be integrate this into t, everything into t. So if you change this, so t goes from 0 to 1, 2x is 60, minus y is minus 0, plus 4 doesn't change, and then dt is 3 dt. This one is 0 because y is 0. Y is 0, dy is 0 in terms of t. Okay, so what's the value for that? So that will be 3t squared plus not 3. This is 6 times 3, so that will be 18 plus 9. 90 squared plus 4 times 3, 12. So that would be, I think I can just take it outside. I think it's better to do that. So 3 times 3t squared plus 4t evaluate from 0 to 1. Okay. So you can see that this is only 1. So 3 plus 4 is 7. 7 times 3 is 20, which is what we get before. All right, let's see on L2. Ada soalan tak setakat? Any questions so far? Any question? All right, no question. Okay, now we go from 3, 0 to 3, 2. Line 3, 0, this line, if you remember on the vertical line, 3, 0 to 3, 2, and t always goes from 0 to 1. You don't have to worry about that, but all you need to worry is how to convert x in terms of t. So x in terms of t, so you can see that x doesn't change in terms of t, and then y in terms of t, you need to evaluate that. Okay, so since x doesn't change, I can say x equals to 3 doesn't have anything to do with t, and then y equals to 2. Because when t is 0, y is 0, t is 1, y is 2 times 1. Okay. Am I going fast? Laju sangat ke saya ni?
Doctor,
Yes.
why is x equals to 3, not 0?
Because let's say if t is 0, x is 3. Is it 0?
No.
No. If t is 1, x is also 3. So meaning that x doesn't change with t. So x has nothing to do with t. So for any value of t, you can see that when t is 0, x is always 3, y is 0, y is 0. When t is 1, x is also 3 because it doesn't have anything to do with t, and then y is just 2 times 1, 2 times t.
Okay, Doctor.
Buat dia constant. Kalau kena faham konsep constant dia. So constant dia tak ada kena mengena dengan orang lain. Dia diri sendiri saja. Right. So next is we need to find dx. So dx in this case is 0, and dt in this case is just 2. Not 2, 2 dt. Okay, so this is also nice because now we have this part is 0, and we have the value of this part. And then we need to evaluate from 0 to 1. Okay, so 5y is 10t plus 3x is 3, 9 plus, so 9 plus 9 minus 6 is 3, and then we have 2dt, because dy is 2dt. So just take 2 outside, 2, this is 10, so this is 5t squared plus 3t, evaluate from 0 to 1. So always evaluate from 0 to 1 because you don't want. So that's the easy part if you do something like this. So you can see that this is 5, this is 3, so the total will be 8. 8 times 2, which is 16. Also the same as we did before. So this is also the same. Now, the next part is from 3, 2 to 0, 0. You need to take some practice if you want to do this time. This is the easiest. I think this is useful. For example, let me show you after this. This is the most useful one compared to the first one. So saya lebih suka guna cara yang ni. Cumanya, the thing is you need to find out what's the parametric equation in terms of t. The nice thing about this t is t always goes from 0 to 1, so that's the easy part. The hardest part is to create the function. All right, the last part. The last part is on line number 3, which is from 3, 2 to 0, 0. Okay, so from 3, 2 to 0, 0. Okay, now in this case, I think that it is better if I do start from t equals to 0, and then this one, no, I start from t equals to 1, and then this one t equals to 0. Why? Because you can see that if I want to do some the manipulation on the equation, I can see that when t is 0, everything is 0. When t is 1, they have some values. All right. So I can do the equation like x equals to 3t, and then y equals to 2t. Because this is just a straight line. So x equals to 3t. Let's say when t is 0, x is 0. When t is 0, y is also 0. When t is 1, x is 3 times 1, which is 3. And then 2 times 1 for y, which is 2. So this is my equation. Okay, so I need to find out the dx. So dx is just 3 dt. And then y is just 2. Right, and then last thing is, so this is, you need to work on the algebra expression, because now this is not 0. This is also non-zero. So you need to put everything back into t. So t start from 1 to 0, because we are going from big number to small number. So 2x is just 6x minus y is minus, no, not x, in terms of t. So 2 times 3, so 6t minus 2t plus 4. So this is in terms of t. Dx is 3 dt. So this looks like Jacobian, right? So you have the function in terms of t, Jacobian, and then the respective derivative. Plus we have 5y, 5 is 20, plus 3x, 3 is 90, minus 6 times 2d. Okay, and then if you evaluate this, you will get also the same answer, which is minus 25. So I left the evaluation as your own practice, right? So 21 plus 16 minus 25 is 12. So that's easy. Same thing. So I want to ask you this question. Which one is easier? The first that we did or this one?
The first one.
I need. The first one.
No, the first step.
The first step, the first method. I think that's because
Yes.
you need to find out this parametric equation. That's why you think this is hard. Okay. Now, and then this is the last method I want to show you. Using what? Using green theorem. Okay. So I think if you already read the SCL problem from the Putra Blast, the third method, I can use green theorem. So teori hijau. Dalam apa ni, dalam yang viral dia kata apa, yang mak kau hijau. Ini pun teorem kau hijau. Green theorem. Okay, apa green theorem kata? Green theorem kata sekiranya the line integral, the region bounded by line integral is closed and simple. So C, the line C, closed. Bukan sebelum itu lagi, simple and closed and oriented this way, counterclockwise. You have integrate from C p dx plus q dy. So this is equal to a double integration on region R q derivative with respect to x minus p derivative with respect to y, which is dA. So this is what teori hijau kata. Okay, so teori hijau kata macam tu. So we need to take advantage of that theory. Mana saya tulisnya? Okay. Okay. So what's P? P mana tadi? P equals, so this is the region dA, and if you remember, the region is this 0, 0, 3, 0, 3, 2. So this is a triangle. So this is a triangle. Let's see what's the derivative of q with respect to x. So q originally is 5y plus 3x minus 6. So therefore, q sub x is just 3. So 5y plus 3x minus 6. Partial derivative q with respect to x is 3. This one. And then p, this is equal to 2x minus y plus 4. So p sub y. T sub y is this guy. So this is just -1. Right, so we substitute this into this equation. So that will be integrate in region R, Q is 3 minus -1 dA. So this one will be 4 of region R dA. Okay. So what's dA? dA, this one is what? This one is area of triangles. These triangles. Area of that triangle. So area of that triangle is what? Is 1/2 base times 6 times that. So this is A is just 1/2 times the width. 3, the height is 2, so this is just equal to. So in this case, it is just equal to 4 times 3 equals to 12. Now, which one is easy?
Green.
This one, right? This one. So
Yes.
now you can see that I can only use how many lines? 1, 2, 3. As long as the region is simple, then just take the area of that region. You don't have to evaluate this because you know that this one is a triangle. You know how to calculate the area of any triangle. If it's a square, it's just base times height. If it's a trapezoid, parallelogram, same thing. So the base times the height. Okay, so this is easy, but this comes with a cost that this is only valid for this condition. Simple, close, and oriented counterclockwise. You need to make sure the orientation is correct before you evaluate the green theorem. Okay. So any questions so far? This is I think line integral is quite powerful. And if it's not close, then you can use method number 1 or method number 2. Remember, if it's not close, meaning that this is just a line. So C, let's say C, this is the curve C. Curve C, this is not a closed curve. It is not a closed curve. You need to bear in mind about that. Okay, so and then multiple integration. I think we have only 20 minutes, so I'm going to touch only a little bit about that. I don't have much more time. Let's see. So multiple integration. Multiple integration. So we have integral. One is the region R. The region R, we have rectangular region. Is it a rectangle? And we could also have something like over a general region. So R can be rectangle, R can also be any region. If it's triangle, is easy. Octagon or something like that, that's easy. And we have a polar region, polar coordinate, when you have something like a circle. So obviously, if you see a circle change into polar coordinate, And we also have some kind of various equations. So in this case, in general, what the multiple integration is, if you want to do the triple integration of x, y, z, dv, okay, and then x is a function of u, v, w, y is also a function in terms of u, v, w, as well as z. Okay. So in this case, our region, let's say also R. So in this case, you can use, maybe this is region S. After you use what? Change of variable. So you use change of variable. Change of variables. You have F in terms of X, U, V, W. Y in terms of U, V, W, as well as Z in terms of U, V, W, U, V, W, and the Jacobian of U, V, W, that is Jacobian, times P in U, V, W. So I'll just write U. Because we are not sure, is it going to be UV, W, or the other way around? Okay. So the key point about multiple integral is Jacobian. Okay. All right. So the Jacobian, I think you need to review about the Jacobian. I'm not going to write that down. Okay. So sometimes triple integral you can reduce into double integration because something are simplified. But you need to bear in mind, what we need to bear in mind is the region type, the type of region. Because the way you choose your region will determine how you choose your boundary integration. Okay, so for example, I don't want you to memorize the type, but I want you to understand how to evaluate the limit for each region. Okay, so for example, if I have this, right? If I have a triangle like this. If I have a triangle, and then this line is y1, this line is y2. Okay, if I want to find the double integration bounded by this region, what's the limit? What's the left part and then the right part on my variable will be? Okay, so then let's try how you look at it. Let's try to put like so x from A to B, and then y goes from this is C to D. All right. So if you take some value, if you take one value right here, so you sit on x-axis, and then you walk along this straight line. Okay, you walk along this straight line. You can see that when you enter this region, you enter on this point, and then exit on y1. Okay. Exit on y1. But if you enter at this point, so you exit on y2. You cannot do that unless you can also do something like this. One of your friends, I think this should be commendable because one of your friend did she divide into two parts. You can also do something like this. You can also say this is thus a two triangle plus this is the sum of two triangles. You can do like this also. You can see that if you enter this line, it will exit and on the same line. This line and then exit on this line. Enter this line, exit on y1. This is, you can do that also. You just separate into two parts. Okay. So another way, this is option 1. Another way is you cannot do this. You can just use one integral evaluation. So you can do something like so you enter on this point on y direction, not y direction, on y x direction, parallel to x axis. Okay, if you take that, as you go up, you can see that you entered y1, you exit on y2. As you go up, you enter on y1, you exit on y2. So you are being constant in that case. So in that case, I can say that my boundaries is just y is constant, line constant. So y in terms of this will be from C to D, and then x is my variation from x1 to x2. So what's x1, what's x2? x1 in terms of y, x2 is also in terms of y2. So that's the thing that you need to pay attention. Okay, let's go to the next part of 10 minutes to go, and which is multiple integral. I'm going to go for derivatives of multiple variables. Chapter 3. Chapter 3, derivatives of multiple variables. Okay, so what do you have here? You have partial derivatives. Let's say df, dx. Because why? Because you need to fix one other variable constant and then only one function not constant. Or maybe I can do something like this. Before that, I forgot. If I have z as function of x and y, okay, and then I have x in terms x a function of u and v, and y x function of u and v. Okay. Now my question is what's the value for so I want to find partial z and partial x. I want to find partial z, partial y. I think this is the other way around. It should be in terms of u and v. Oh, that's better because of that line. Should be the other way around. So u in terms of u x y and then all right. Now that's what I meant by that. Okay, so what we do in this case, we do the tree diagram. You can see that z is depending on u and v. U depends on x and y. V depends on x and y. So if you want to find z partial with respect to x, you need to go on this line plus this line. So that's the chain rule, right? So you need to go dz over dx. So this is just delta z or delta u times delta u the x plus, which is this line, okay, and then plus this line. Plus delta z over delta v plus delta v over delta x. So you need to trace the chain, okay, and then you can do the same for. So this happens if you have explicit derivatives. So this is explicit because why? Because z on the left hand side, the expression is on the right hand side. Okay. I want to leave you one question. I'm going to do some part of it, and then you can try to solve on your own. Okay. This is proving. Okay. This is explicit is easy. Let's do the hardest part. Now I don't have time to go for maximum and minimum. I hope that you study on your own. All right. Let's see this one. Example. This is in. I have u3 plus b to the power of 3 equals to x plus y, and I have u squared plus b squared equals to x cubed plus y cubed. Okay. And I want to show that one over two, the Jacobian of u and v with respect to x and y, u and v with respect to y equals to 1 over 2 y squared minus x squared divided by 2 u minus. So you need to show this equation. Okay. So you can see that this is not easily expressed everything to the right hand side. So you can, this is like this is implicit function. Implicit function. So in that case, you need to learn how to do derivatives for implicit function. Okay. So what we have, let's try to try to do our first step. So this is in terms of u, and the numerator is u, denominator is xy. So in that case, we have, so the Jacobian of this is u in terms of x, u in terms of y, v in terms of x, v in terms of y. Okay. So you need to find u sub x, v sub x, g sub y, u sub y. Okay. I want to do one equation, maybe, and then you can do the rest. All right. So first of all, we need to find this in terms of x, because I want to find out my first derivative expression. Okay. So so I want to take this first in terms of x. Uh, 3 minutes ago. So take that in terms of x. What do I get? So this one in terms of derivative. So take partial derivatives with respect to x for u cubed plus b cubed equals to x plus y. Okay, so this equals to, so you need to remember this is a function of xy, this is as a function of xy, this 10 by itself, this 10 by itself. So this one will be 3u squared times u sub x. So right, I prefer to write in that notation because you don't have the fraction. And then this is plus 2b times b sub x. Not b sub x equals to 1. Right, and then I take the second equation, also with respect to x, u squared plus v squared equals to x cubed plus y cubed. So this is equals to 2u times u sub x, and then plus 2b times b sub x equals to 2x squared. Okay, and then you can do I think you can put it into metric form. So this is like 3u squared, and then that will be 2b, 2u, 2b, and then this is u sub x, b sub x equals to 1. All right. You can use Cramer's rule if you like. You can just, I think I prefer to use Cramer rule because it's quite neat if you want to have 2 by 2, and because you also have this variable expression notation. I think it's better to use Cramer's rule to solve for ux, and then you can solve for vx. So we have the first column, ux sub x, and then you can find the v sub y and so on. All right, so we are out of time. So if you have any questions, then you can always message me. All right. Okay, and also if you think that it is better if I use whiteboard instead of writing on the computer, please let me know, because I can always change my presentation method. Okay, so thank you everyone. Assalamualaikum, and Good. Midday. All right. Bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Take a note.